Good day guys, this is Miss Ru from Mathematics Hub. Today we want to look at completing the square, and we are going to complete the square on quadratic expressions, and we're going to use the method to solve some equations. So when we complete the square, we are transforming a quadratic expression of the form ax squared plus bx plus c into this form here, where we are having a times x plus b over 2a squared plus c minus b squared over 4a. In other words, when we complete the square, we are expressing a quadratic expression in the form of a squared bracket, and we add a constant if necessary. So let's look at an example. In this example, we want to complete the square for x squared plus 6x plus 1. So take note, a is 1 because a represents the coefficient of x squared, and then b represents the coefficient of x, and then c is just a constant. So in this case, our a is equals to 1, b is equals to 6, and c is equal to 1. So if we are to take those values and then we plug them into the formula that we had on the previous slide, then we will get our answer to be x plus 6 over 2 squared plus 1 minus 36 over 4, and simplifying that will give us x plus 3 squared minus 8. Let's look at another example. We now want to complete the square for 3x squared minus 4x plus 5. In this case, our a is 3, our b is minus 4, and then our c is 5. So we plug this into the formula, and then we have 3 times x minus 2 over 3 squared plus 11 over 3 is our answer. So it's just a matter of substitution. In our next example, we want to solve an equation using the completing the square method. So we are going to solve x squared plus 7x plus 12 is equals to 0. Firstly, we are going to complete the square on the left hand side. We're going to complete the square on x squared plus 7x plus 12. If we do that, we will get that x plus 7 over 2 squared plus 12 minus 49 over 4 is equals to 0. And then we take the constant to the right hand side, and then we have x plus 7 over 2 squared is equals to 1/4. And now we want to do away with the squared. We want to do away with the power 2. So we'll introduce the square root sign both sides, and then we will have x plus 7 over 2 is equals to plus or minus 1 over 2. So that will lead us now to having x plus 7 over 2 is equals to half, or x plus 7 over 2 is equals to minus half. Simplifying these two equations will give us x is equals to minus 3, or x is equals to minus 4. In all the examples that we have looked at so far, we were just using a formula and we were inputting the corresponding values for respective variables. So now we want to see how do we derive that formula. Now we want to see the steps that we consider when we are completing the square. We want to derive the formula. So let's consider our quadratic expression ax squared plus bx plus c. The first thing that we're going to do is to factor out a, so that we make sure the coefficient of x squared is 1. So if we factor out a, we have this expression here within the bracket, x squared plus bx over a plus c over a. And then we divide the coefficient of x by 2, and then we square it. After squaring it, we add and subtract b over 2a squared. So this is what I've done here. I added b over 2a squared here, and then if you see here at the very end, I subtracted the b over 2a squared. The next step is for us to factorize and to simplify. So if we are to factorize this part, if we are to factorize x squared plus bx over a plus b over a squared, then we get to this step where now we are having x plus b over 2a squared. And then outside the bracket, we have c over a minus b squared over 4a squared. And then we now remove the big brackets by multiplying by a. We multiply by the a that is outside, and then we get to our formula that we have been using in our examples, which is a times x plus b over 2a all squared plus c minus b squared over 4a. And that's the derivation of the formula that we have been using. That will be all for today. Thank you for watching. We meet again in the next video.